Hello, welcome to 7.3 Logarithmic Functions, and we're working problems that are in the book on page 509, and if you're looking at the PDF, it's page 24 on the PDF, because it's just chapter 7. And we're going to do problems 10, 11, 12, 13. Evaluate using mental math. What this is telling you in the directions is, you can do this in your head. Don't make it harder than it needs to be. So, log base 7 of 343. What does that mean? So, and I'm going to have to write because I'm showing you what I'm thinking. I am thinking 7 to what power, because I'll use x because I don't know, equals 343. So in other words, the logarithm is the exponent, so what's my exponent here? Okay. Now, before you panic and say, I don't know how to do that, maybe you do. You know 7 to the first power equals 7, and you know you can do this in your head. 7 to the second power is 49, you got that. So what about 7 to the third power? That would be 49 times 7. Okay, so let me help you out with this. This is mental math. You can do this. Use 50 instead of 49. So I'm going to do 49. I'll write it right here. 49 is 50 subtract 1. So if I multiply 7 times 50 and get 350, and 7 times 1 and get 7, subtract, I get 343. Yay. That's a 4. Sorry, it looks ugly. So how many times did I multiply 7 in my head? Once, twice, 3 times. This is 7 to the third power. So this equals 3. The exponent is 3. Number 11, 3 to what power equals 1 over 9? There's two things happening here. First, I know, and again, this is in my head. This is what I'm thinking. I don't have any, I'm not organizing it. I'm just showing you what I'm thinking, okay? I know that 3 squared equals 9, so that's useful. And I also know that 3 to the negative 1 power is the reciprocal of 3. So if I put these two together, 3 to the negative 2 power should be 1 over 9. And that's true. So this equals negative 2. The exponent is negative 2. For number 12, don't panic about the decimals. This is not bad. My base is 0.5. I'm trying to find what the logarithm equals. The logarithm is the exponent, so my exponent's what I'm trying to find. Same thing here, same thing there. And this equals 0.25. All right, so maybe you recognize it right off the bat, maybe you don't. So you can start trying this. 0.5 to the first power is just 0.5. That's not it. 0.5 to the second power. So, all right. This is where fractions are really useful. This is 1/2 and this is 1/4. If I do 1/2 times 1/2, I get 1/4. So that tells me that 0.5 times, use an X for times, 0.5 should equal 0.25. So my exponent is just 2. And that's not too hard. You can do that. Finally, for the last one, very, very, very similar. 1.2 to what power equals 1.44? If I remember my perfect squares, I remember that 12 to the second power equals 144. So maybe this is 1.2 squared. And and again, this is in my head, I'm just writing it. So 1.2 times 1.2, that's going to be 144 with the decimal point right there, and that's what I have. So this equals 2 again. I know that they look hard, but they're really not. And why do we do this using mental math? Because we're just trying to train your brain into thinking. The only purpose for this is to recognize that the logarithm is just the exponent. And as we finish chapter 7, as we go through chapter 7, there's going to be times where we're going to be working on stuff and we'll get to a part where it'll have something like this, and it's almost funny. It's like, guys, you know what that is. And there's this moment of panic because, I don't know, it's like you can't see the forest for the trees, as the saying goes. And I'm like, everyone together, the logarithm is the exponent. And then people, oh, and then they figure it out. So hang on to that thought because you're going to be seeing that later. See you in the next video.